So in the last few classes, we have discussed about supervised learning a lot. Supervised learning means when I have a y variable and I try to predict it with the x variables. That we have done quite a bit. But we have missed the unsupervised learning part, where you have to create the y variable first. We do not have the y variable. You have some features, some characteristics of the data, and based on those characteristics kind of a data, you try to create a you try to create a new I would say tagging of the data. So based on the characteristics, you try to tag that. You try to see that whether this variable is this particular observation is in group 1 or group 2 or something like that. So that will be something that we are trying to do today, and this is we also use this in the context of business in the context of customer segmentation a lot. So what is a customer segmentation? Let's talk about that first. So the broad business questions that we try to answer using customer segmentation kind of problems, and it can be used in other segmentation problems as well. That which customers from my customer base creates most revenue and profit. So if I can break it based on that, or which of the different tier 2 cities of India should a multinational wholesale retail chain target for entry? So can I group my cities depending on certain characteristics of the city? It can be the size, it can be the population, it can be the average income of the people. It can be various other things based on which one city can be close to another city. So can we create a group of those cities where you can try to target? Whom should I target for my online and offline campaign? Can I club the customers based on their campaign proneness? So there can be so many ways you can use this customer segmentation. Why we generally try to do this segmentation? Because in most of the cases, whenever we try to do customer segmentation or any kind of segmentation, we are not able to tackle the whole thing, all the group of people. We generally try to focus on certain groups of people or certain groups of observations or certain groups of the like cities, as I was talking about, so that we can focus on them. So we generally have some amount of constraint in terms of the capacity to handle all of them. The profitability can be an issue and etc. for which we do this segmentation. And segmentation is generally done after profile, before profile. Means once you create the segment, based on the demographics and psychographics of the person, you try to create a profile. You try to name the segments. So there are certain methods of segmentation. I will go directly to the data analytics side. I will application side. You will learn in a business analytics course probably. But this data analytics side is something that is more important. The algorithms are more important in this particular course. So we'll talk about these three algorithms mainly: hierarchical clustering, Watts method, and K-means. There are other kinds of algorithms that are there in segmentation, but they are still in the research phase. So we will talk about these three algorithms mainly in our in this particular class, and we will also try to implement that in our class. So what is hierarchical clustering? So hierarchical clustering starts from either all the persons in the all the observations that you have whom you want to cluster. Either they start from putting everyone in one cluster, and slowly you break as per your wish, or you put everyone in 5 different clusters. Every individual is separate cluster, and then you slowly join them. So it can be any one of them. So when you try to do that, when you either join them or break them in one of them, you call it either agglomerative clustering or divisive clustering. When you start ABCD in one group and then break AB and CD and then further you break. So that is called divisive clustering. So how does it happen? For example, first one, if I see ABCDE, I want to break it into 2 groups. What are the possible groups that I can create? I can create A in one side, B, C, D, E in another side. I can create B in one side, A, C, D, E in another side, C in one side, A, B, D, E in another side,
D in one side, A, B, C, E in another side, and E in one side, A, B, C, D in another side. These are the five options. Then I can put AB one side, CD one side, another side, AC one side, BD another side, AD one side, BCE another side. So many different combinations of breakings can be created. So once I create all the combinations of breaking that is possible, we check that which of these two groups that are getting created now has the highest distance. So if I have to do that, then I have to have a mechanism to measure how two groups are distant from each other. There has to be a way of measuring that how two groups are distant from each other. So two groups are distant from each other. We measure it based on these three or four terms basically: single linkage, complete linkage, average linkage, and centroid linkage. Let's talk about what these things are. What is a single linkage? What is a complete linkage? What is an average linkage? And what is a what is a centroid linkage? We will quickly discuss that. Just one minute. So let's say if I just add one blank slide here so that I can write something. So let's say I am trying to find out how these two groups are distant from each other. Let's say this is one group where two observations are there, and this is another group where three observations are there. So A, C, D. So the distance between A and C is this. This is the distance between A and C. Whatever way you define, there are different ways of defining a distance. We'll talk about that quickly, but these are the, let's say, the distance between A and C. Now, what are the different ways of distance can be created? So one first of all is single linkage. Single linkage is minimum of all the five distance that is getting created. Just one. Again, so it is the minimum of all five distances. I means AC, AD, AE, then this BC, BD, okay, all six distances. Sorry. So 2 into 3, right? Well, the minimum of that is the single linkage, which is basically the closest. Then complete linkage is nothing but the maximum of all these things. Maximum of all these things. And average linkage is obviously the average of all these things. Average of all the six distances. So you can choose which one you will want to do, but this is how the distance gets calculated. Centroid distance is something else. Centroid distance is like you find out the centroid for this, means the centroid of A and B is basically the average of A and B. And centroid of CDE is the average of CDE. And then you calculate the distance between the centroids. Centroids. So that is basically your centroid distance. So you can choose any one of these distance method that you want to do in this particular case. Now, distance, how does the distance gets measured? I told that, okay, A and C, we will try to find out the distance. What is A and C? Let's say there are two variables. These are my 7 customers, let's say. And the A customer has brand awareness 3 in a 1 to 7 point scale and price sensitivity as 7.
and the C candidate, which is 5 and 6. So then there are different ways to calculate the distance between A and C. What is the one way? One way is, one way of measuring this is called Euclidean distance. So Euclidean basically distance is xa minus xc squared plus ya minus yc square. If I am trying to find out A and C's distance, then this will be the, and then square root of that. So that will be my formula for Euclidean distance. However, the same will be, this is not the only distance that we use. We sometimes use Manhattan distance. Manhattan is basically mod of this. Then there is something called Mahalanobis distance. There are different types of distance that is there. Which one you will choose, again, it's a trial and error method basically, which one is giving the best result. So one thing is the choice of how to measure distance between one observation and another observation. The second is how to measure the distance between one group and another group, because group and another group will have these four choices: single, complete, average, and centroid. And each of these choices will have multiple ways. So single Euclidean, single Manhattan, single Mahalanobis, similarly complete Euclidean, complete Manhattan, complete Mahalanobis. There will be different ways of measuring these distances. Now, whatever way you choose, once you calculated the distance, the way of calculating the distance, this ABCDE can be broken, as I just told. ABCD can be broken into various combinations, and you choose that combination which gives you the highest distance after breaking. Based on that, you break one. Based on that, you break one. Once it is broken, next step, you try to see that if I want to break AB into two groups, A and B, and if I want to break CD into two groups, either CD and E, or C and D, or C and D, these are three options available. Which break, out of these four breaks possible, which break will give you the highest distance again? Now in step 3, you see that, okay, instead of breaking AB, if I break CDE into CD and E, I will get the highest distance. So that is the second step, and so on. So you keep on breaking till all the individual observations are in one, not one group. Each of them will have a separate. Till that point, you keep on breaking. On the other hand, in an agglomerative clustering, actually you do the reverse. You start with putting everybody into separate groups, and you slowly go ahead and join them one by one. So once you join them one by one, you try to see that which one is the closest, and then you put them into the same group. Like out of A, B, C, D, E, A and B are the closest. So you first join them and make a group of A, B. So if you can calculate the farthest, highest distance, you can also calculate the closest distance. So that's what we are doing. Now, this is called hierarchical clustering. The easy method of doing it is like this. For example, here we have created a matrix, like, and we are doing agglomerative clustering. That means we have kept everybody as separate, and we calculated the distances between each of them. The diagonal elements are 0 because all the observations are absolutely equal to their own observation. That means they have 0 distance from themselves. So that's why the diagonal elements are 0, but the off-diagonal elements have some value, and you are trying to measure the distances. So based on that, if I calculate, you will get that B and C has a distance of 1.414. I think they have used single linkage. Of initial level, there is no single linkage, complete linkage, because everybody is in one. Every observation is separate, so it doesn't matter. But they have used Euclidean distance. And you can also see C and E are also 1.414. So you have a choice. You can either join B and C, or you can join C and E. So First step, let's say I joined. Oh, okay, I have drawn it here. Sorry for that. Just 1 minute. So I have joined, let's say, uh, B and C I have joined. And again, after joining, now BC becomes one group and I followed single linkage. Now, based on that, I again calculated the distances. I got all the matrix values. Now I can see that if I join BC with E, remember C and E was 1.414. So if that means BC with E will also be 1.414 because we are following single linkage, the lowest of the distances. So that is coming 1.414 here. So if you are getting 1.414 here, then I can join BC with E. So in the next step, I'm joining BC with E. Again, calculating the distances accordingly. And then I will join probably A and D. So I have joined A and D. And then I will join probably AD and BCE or AD and AF, any one choice. AD and BCE I joined. So I got this and so on. Now the question comes up is that, should I have everybody as separate segments or should I have everybody in one segment? And if I want to do something in between, what should be that in between? What should be the number where I will stop my cluster? So that follows a certain method. What we do is that the number of clusters and the distance that is covered through agglomerative clustering, the distance that is uh, that gets joined through agglomerative clustering, we plot that. And then we plot that and we look for this kind of an elbow. You see, this elbow means what? This elbow means that if I have more clusters than more than five clusters, then the values are quite different. If I have less than five clusters, then the cluster values are more or less similar. So within the cluster values. So 5 is the optimal number after which the cluster values are getting pretty different. They are not within the cluster, all the values are not so close by. So that is this meaning of this elbow kind of a thing. Means before that the curve will look something and after that the curve will be more flat. So that's what we look for. So 5 cluster means I will stop at this level. So A, D, F, G, and B, C in one cluster. This is where I will stop. So this is normal method, which is Euclidean distance based or Manhattan distance based method developed by which is hierarchical clustering. However, Watt's method is a little bit different. It is also hierarchical clustering, but the way you measure the distance is something else. So what we rather measure is that, if you remember in the F test, we talked about this. In the F test or regression, we talked about R square values, right? In the R square is what? R square is the 1 minus, if I just write it down here, this 1 minus ESS by TSS. And what is ESS and what is TSS? This is the total sum of square before you have done any modeling, any clustering. What does this mean? This means basically, if I have A, B, C, D, E, F, G, 5 values, if I have these 5 values, A, B, C, D, E, F, G, and if I also have, I know that out of A, B, C, D, E, F, G, let's say, I know, or I randomly put them like this, that these 2 are in one segment and these 4 are 5 in the second segment. Okay. And then what do I get? So I am saying that there are two segments, I and 1 and 2. Basically, there are two segments, 1 and 2, which is I. And in each I, there is some J. J, this is the segment identifier. J is the observation and K is the variable. There are K variables, let's say X1, X2, up to Xk. That many variables are there. So there are K variables, I segments and J observations. So for X, I, J, K, and I varies from all the I, all the J, and all the K. X, I, J, K means any random value here. Let's say this person's. So when I is equal to 2, J is equal to 1, and K is equal to 2, then X2 of this observation comes up. That minus the mean of all the observations together. So all the observations, all the 7 observations together, you got a mean of x1, you got a mean of x2, you got a mean of x3, dot dot means all of the all. So basically you get a observed mean of xk. So that is the total sum of square. That you squaring it up and then adding it for all the observations. First you add for this observation. So you are basically trying to find out the variance of the overall data with the means of the overall data. Now you are doing the same activity separately. You do not finding out from x double k, but you are finding out from xik. Xik means you got a x11 dash, x12 dash, x13 dash, which is just the mean of A and B, and then x21 dash, x22 dash, and x23 dash, which is just the mean of C, D, E, F, G. That means you have calculated. So that's why what do I get? I get xik dash and square of that. So these observations are the distance of these observations from this means are calculated, and A and B from these 3 means are calculated. So this is the sum of square after the segmentation. Basically, this is measuring that after segmentation, within segment variance. And this is measuring the total variance, total sum of squares. So that means this divided by this is the amount which you cannot explain till now, which is still there, which the variance is still there within the segment. 1 minus that is the amount that your segmentation can explain. That is your R square value. So 1 minus this value is your R square value, which is the segmentation, which is the amount of variance of the total variance, which your model, which your segments can explain. Now this I calculate. Instead of calculating the distance, if I do it like this, that when I join, first I check the R square. Initially, everybody has the R square is 0. Why the R square is 0? That every segment is separate, right? Every segment is separate. So if every segment is separate, then I have absolutely no distance from my mean. So if every segment is separate, what will be the value of ESS? Xijk and Xi dash k will be same because only one observation is there in each segment. So ESS will be 0. This value will be 0 when I have only everybody has separate segment. And then that means R square value will be 1 here in a words method. And these values will be R square somewhat lower than 1, somewhat lower than 1, somewhat lower than 1, somewhat lower than 1. And I will basically break based on whichever is giving this delta R square highest. Whichever are closest, if A and B are closest, then the delta R square will be less. So that I will take. So whichever has in a agglomerative. In the agglomerative, I will check that whichever two observations, if I join, the delta R square will be the lowest change. That I will join. And in a divisive, I will check for highest delta R square jumps. That those I will split. So both will give you the same result, whether you go for agglomerative or divisive. But this is something that you focus on, the delta of this R square. So that is how Ward's method is still a hierarchical clustering method, but the way of calculating the distance is different. You rather don't calculate distance, you calculate this R square value, and based on that, or ESS value at least, and based on that you calculate the distances. Now these are the two methods that are basically that depends on the data size. The larger the data, the more difficult is the calculation. There is another simpler method which have been found out, which is k-means, which is also found to be very useful method, and we will talk about that. So, what is the k-means method of clustering? So, in this method, I put them, let's say A, B, C, D, E, and G, the same observations in a two-dimensional plane. I had two variables x1 and x2. That's why I have put them in a two-dimensional space. If I have multiple variables, let's say x1 to xk, then I would have it would have been difficult to think, but I would have put them in a k-dimensional space. That means each observation will be a k-dimensional vector from 0, 0, 0, 0, 0, 0, 0, 7 zeros, which is 7 dimension. I will go up to that particular value, and that will be a vector. So k-dimensional space I will create. But here I have only two variables like brand awareness and price sensitivity, to remember. So I have two-dimensional space, I plotted them. And then I randomly assign two values. So how many values? Why 2 or why not 5? Why not 6? This is what is my choice. So we randomly assign, and how to decide that choice, I will come to that just a minute. So let's say I decide on CC1 and CC2, two values. So I will say that I will break it into two segments, and CC1 and CC2 are these two centroids. So these are randomly chosen, CC1 and CC2, in this two-dimensional space. Then whichever observation is closer to CC1 are assigned to CC1. Whichever observation is closer to CC2 are assigned to cluster 2. So I assign them based on the distances. Now CC1 and CC2 is randomly chosen. So I slightly changed both of these observations. I changed their delta x and delta y, some position change, I do that. And the moment I do this position change, some of the cluster gets jigged up. For example, if you see after this change, the E observation, which was previously in cluster 2, now comes to cluster 1. Again, I change. And I keep on doing this iteration. I keep on doing this iteration till everybody gets settled. Every observation gets settled, or a very large amount of time. So I decide that I will go for 20,000 iterations, and then I will stop. So that is one way of clustering. Now, based on whoever after the iteration of 20,000 observations, wherever you find out whichever variable to be falling, you assign them to that particular set. The problem with the previous one and this one is that in the previous one, in every step you have to do your calculations. Here, it is probably much easier. It's in one, it does not depend on any kind of statistical thinking process. In a multi-dimensional space, this becomes easier to calculate. However, it sometimes gives very accurate result without any underlying theory. It still gives very accurate result. However, this is an iterative method. It does not have underlying way of thinking that why I should do that, why not that. While hierarchical clustering has some logic at the end. However, we have seen both of them stands pretty well as long as we're. Now the question is that which one will I choose? Which one, how many segments will I choose? Or will I choose 2 segments or 5 segments in k-means? That also comes from the same WSS calculation within sum of square calculation. So we calculate this value, this particular value within sum of square, this ESS value that I have written in this formula. When I choose, let's say I have chosen k is equal to 2. I found out 2 segments. What is the ESS value? Then I choose k is equal to 3 and I run the 20,000 iterations again. Got 3 segments. What is the ESS value? Then, like that, again I choose k is equal to 4. Again 20,000 iteration. What is the ESS value after that? So, like that we do for 4, 5, 6 cases I do, and whichever cases the ESS value is the lowest, we choose that. In fact, not the lowest, we choose the optimal. So ESS value will be the lowest, as you know, when k is equal to the number of observations exactly. But we look for that same elbow kind of a sign to check that whenever after that probably it gets saturated. So wherever the inflection point is there, before that there will be a very steep drop of ESS, but after that the ESS's drop is further flattened. That will be our optimal point because that has the highest informational value. So at that point we choose our k. Let's stop it. So let's say if I do this activity and then if I plot it like this, if I plot it like this, and when k value was 2, ESS was like this. When k value was 3, ESS was like this. When k value was 4, ESS was like this. 5 it is like this, 6 it is like this. So the curve if I draw, it looks like this. So then this is the point. Before this point, you see that the dropping is pretty steep. After this point, it is flattened. That means what? By increasing the cluster number from 4 to 5, 5 to 6, I cannot drop ESS much. So the new clusters are not explaining much of the data anymore. So that is the point I will stop and I will choose that as my number of clusters. Any question on these two methods, words and k-means? Okay. So if you do not have any question, we'll go ahead and talk about the implementation of it. So let's start my notebook. I will share this code with you. So what I'm doing is I'm as usual importing NumPy, matplot, which helps in plot, pandas, which helps in data reading the data, sklearn cluster, which is a basically sklearn helps in model building. So here we are doing cluster analysis. So we are calling the cluster library only cluster module, and we are using agglomerative clustering. If you see, which is one kind of hierarchical clustering, and we in a hierarchical clustering we write it as SAG. So SCS, so I'm running this. The data set is small customers CSV data set. I've read the data set. If I want to see the data set, I'll quickly show you that how the data set looks like. Data set. Yeah. So you see that the customer ID is there, gender of the customer actually will be. So that is there, age is there, and we have two major variables: the annual income and the spending score. You can have multiple variables as well. Now, one good way of starting is that what we generally do is sometimes if we have too many variables, we have to normalize them before we go and uh, change the analysis, do the analysis. So here I will deal with only the third and fourth row, which is 0, 1, 2. So third and fourth column. So I'm choosing third and fourth column and the values only, not the headers. And I'm putting it in X. So if I run that, my X looks like this basically. It's an array of two arrays basically. So two observations. Now I create a dendrogram using words method. Dendrogram looks like this. So I'll quickly run that, just 1 minute. So if you see, what is a dendrogram? Dendrogram is every observations. So it's an agglomerative clustering. So in the left side, in the x-axis, the distance is measured. That when I join somebody, how much distance I'm covering, and in the lower side, each of the observations are kept. So if I want to show the copy the image and I can make it bigger. Yeah, so these things are not getting reported. So each of these are one observation, and two observations are getting added here. You see, and this much the height of the of the rectangle kind of a shape is the basically the distance that is getting covered by after joining these two. So that is getting plotted here. So if I can see properly, then I may go for this all the orange as one segment and the greens and the red ones as two segments. Somebody might want to break this orange into two segments again. Probably, let's say, uh, probably this part of the orange as one segment, this part as second segment, and all this part as third segment. So orange can also be broken into three segments, but blue, this one probably have two prominent segments. So either 3 or 5 is a good choice. Instead of what I do it is, let's say I can also plot it. I do not know whether I have plotted. I will show you how to plot this curve, the elbow kind of a curve. So just 1 minute. Yeah. So what I do is that I write model is equal to agglomerative clustering, and cluster is equal to 5. Affinity is equal to Euclidean, that means Euclidean distance we're using, not linkages is what, and then I'm using that with the data set of X. So that gives me the model model.fit X, and levels are basically model.level. So if I run this, I get my model. So if I get the moment I run this on the X data, this agglomerative clustering with number of clusters as 5 is getting calculated. Now, is there a way to calculate the ESS? Just 1 minute. Let me just check. Just 1 minute. This is I don't know exactly how to calculate the within cluster SS in agglomerative clustering. Should have checked that. I'm searching this quickly. Yeah, so this is how they're doing clustering and this is the plots, but how do they calculate the WCC? So we have to check that. I am not very sure that how you are getting this. I have to find out the W, how to calculate the WCC here. I will quickly find out and let you know. So what you can do is that if you by chance can calculate WCC, you can plot it. I will show you how to do that. Anyway, so now we can plot it in this curve, which is basically there are 5 different plots are getting created. I can also create probably a level plot. So you can put a level for each of them. So level is going to cluster one, level is going to cluster two, and so on. Put that. So let's say level is equal to cluster one and so on. This one can be cluster two, this one can be cluster three, this one can be cluster four, this one can be cluster five. The moment we do that, the levels comes in. So let me run now. If what happened to the level? MTP reject. That we have to do. Yes, the legend is there. It will not show. The legends are there. So this is how we can create the cluster, the plot. Now this is based on Watt's method. The moment we try to do it with k-means method, the cluster will slightly change. So here I am importing k-means and I'm creating a WCC list, which is basically a blank array which will append. And here what I'm appending with is k-means dot inertia. I am pretty sure there is something like that in in, uh, in agglomerative clustering also. So what is that particular parameter we have to find out? And then I'm plotting that from 1 to 11. I'm plotting that. So I'm basically choosing k is equal to 1 to k is equal to 11, and based on that, I'm plotting. So these are the values that I'm coming up. So I can either choose here, which is 3, or I can choose 5. These are the two elbows that is coming up. So here we are choosing 5, and then we did the k-means once more, and then we have plotted it once more. So the plots are coming like this. So you will see that some of the observations, like these observations, which is the borderline, will be different. Will, let's say these are red, not reds, these are blues here, which are close by. But in this condition, some of them are greens basically. That means some of them are basically in this segment. So there will be slight differences in how the segments are coming up, who is coming under which segment. But you can now know that which person is in this segment. Based on that, you can create your further analysis. You can know that you can clearly see that there are 5 clusters that are coming up. In one cluster, the annual income is high and the spending score is low. That means although they are rich, they are not spending a lot. So these are your potential future customers. They has to that they are not spending on you means they are probably not very uh, stingy people. They are basically uh, spending somewhere else, but in your mall they are not spending. On the other hand, peak ones are your most profitable customers. They are spending a lot also, and their annual income is higher as well. On the other hand, there are people who are spending a lot, but the annual income is not so much, which is the blue one. So you have to have a way to make them. So if you can do give them some discounts or etc., they will be very happily accepting that. Then the red ones is some of the customers which you do not want to focus on, and the blue ones you will try to bring them, if possible, either uh, to the zone of in between this sky blue and pink. If you can push them towards that direction by giving certain kind of discounts and etc., that will be very helpful. So I think the discounts that I was talking about should be more targeted towards this middle income group rather than the lower income group. So don't give discounts to very cheap products. Give discounts to products which are pricey products, which the middle income group aspire to buy, but they don't buy. The spending is also middle. So in those kind of products, if you can give your uh, discounts and etc., that will work. So that's it. Basically, there are two codes. One is this k means, which come both of them comes under this scalar k means and agglomerative under the clustered package. Here it's a scalar cluster package under that agglomerative clustering, and here the scalar cluster package under that k means. So both of them will give you this kind of cluster analysis, and then you can plot them. So we'll stop here. That's all on cluster analysis. We have covered quite a few things in this course. I will ask you to practice that uh, in your time. And if you have any questions, any feedback that you want to share, anything that you want to ask me, you can always write to me.